Hi everyone! In this video, I want to show you how to use GeoGebra to approximate definite integral. Alright, so first of all, we open the GeoGebra app and here we can right click and we can change the graphic. So I want to show only the major grid lines. Okay. So first of all, we want to input a function. So in the inputs, we can type our function. Let's do f of x equals 3x minus 1 cube and minus x squared times sine x. Okay, so how about I also want to let me add 4. Okay, so this is the function we have. Okay, so we can zoom it and a little bit. Alright, suppose we want to calculate the area, the integral from 0 to 2. So let's input 2 points. So point A is 0 and 0. And point B is 2 and 0. So I want to calculate the area under the curve from x equals to 0 to x equals to 2. Okay, so this area. So what do? Let's create a slider. Okay, the slider is gonna be the number of rectangles we want to calculate. So this class we want to see the Riemann sum. How does the Riemann sum actually converge to the definite integral? So we click here, we choose the slider, and we click here. Let's put the slider here. So the name is n. N is the number of rectangles we want to cut, and the number smallest is 1 rectangle, and the biggest, let's do 100 rectangles. The increments, let's do 1. Okay, so that represents the number of rectangles we want to cut. And then next, so here, inputs, we want to do the upper sum, so we enter upper sum. So upper sum equals upper sum. So and I want to input my function. My function is f, and let me see. The start x values is 0. Okay, so that's the point A. Is 0. You can also, if you want to calculate the integral from other x values, feel free to do that. The end value is 2. The number of rectangles is n, like our slider. Okay, so this is what we get. And let the n be smaller. You can see when the n change, that is the, make sure sometimes when you click it, make sure you have this arrow. It means you want to move things, right? Otherwise, you just create more and more sliders. So that is the upper sum. When n moves, you can see the number of rectangles move. Okay, so we have the upper sum. We also want to build the lower sum. Okay, so how do we build the lower sum? Well, the lower sum, first of all, let me move this here. Okay. All right. And how do we build our lower sum? So lower sum. I want to call it lower sum. That is lower sum. Function is f, and the star value is 0, and that is 2. Number of rectangles is n. Okay, so let's change the color. So we right click and change setting. So you can see, let's change my lower sum to be about let's see. Okay, how about green? And my upper sum, how about I change my upper sum to be pink? Okay, how about that? So when n changes, you can see my upper sum, my lower sum changes. Okay, and what happens if we want to know the difference between them? So in the input label, we can select the difference. Okay, so difference is, so difference equals upper sum minus lower sum. So that is the difference. Okay, let me move my lower sum here. Okay, so the difference is here. So if we want to show the difference, let me see, can we? So this is the difference. We move it here. So now you can see the upper sum, the lower sum. When n is bigger, 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 the difference is smaller, smaller, smaller. Okay. Next, how do we compute the actual integral? So if we want to compute the actual integral, we can just enter integral equals integral of the function. So we want to choose function start value and end value that will give us definite integral. Okay, so function is f, the start value is 0, the end value is 2. Okay, so that is the integral. Now you can see the integral is orange color. Let me see, can I change the color? Let's change to how about okay, so maybe let's change to yellow. Okay, so that is the integral. Okay, let's move the integral here. Okay, so you can see when n is getting bigger, 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 our upper sum and the lower sum actually converge to the exact integral. Okay. So if we can also click the animation here, then you can see when n changes how the upper sum and lower sum are converging to the definite integral, and you can see the difference between them. Okay, so this is our projects. How do we share our project to public? So on the right upper corner, you see these 3 horizontal lines. We can click share. And then it will ask us to save. So we want to save it as, this is Cal 1, and we use GeoGebra to, approximate definite integral. Okay, and make sure here you click shared, not the private. Okay, so if you don't see this option, maybe you want to log in and save it again. Okay, so make sure you click the shared one, and then after you save it. Okay, so after you save it, you will get a link. So copy that link, and then we can choose a web browser. So sorry. Okay, so let's choose a web browser. Open a web browser here. Okay, and enter that link. Okay, now you can see our project here. Okay, we can zoom in and we can see when the n goes is how the upper sum and lower sum converge to the definite integral. Okay, thank you for watching. Bye.